Greetings, folks, and welcome to the Electromaker podcast. Now, this week we have quite an exciting sort of dual release, although one of them isn't so much a release, one of them is an announcement. But the big news of the week is that the Nordic NRF 7002 development kit and the IC itself is out and available to buy. Now, I do go into more detail in the show about it, but in short, this is Nordic's first Wi-Fi chip. It is a companion IC, so it is designed to work with the rest of their Bluetooth Low Energy chips, but it will work with anything. You could stick this thing next to an STM32, and it would give it Wi-Fi 6 capabilities. And there's a number of reasons why Wi-Fi 6 is incredible, and I don't have time to go into it here in this introduction, or indeed in this show. I'm going to do a feature on Wi-Fi 6 at some point soon, because it really is the sort of last part of the puzzle for getting IoT Wi-Fi stuff to work in a way that's acceptable for battery life, really. So yes, there's that. But the reason there's such nice symmetry here is that we're talking about Nordic's first Wi-Fi chip. We're also going to be talking about ESP32's first non-Wi-Fi chip. At least I believe that is the case. I may be wrong about that. But yes, the ESP32P4, I believe, is what it is called. We talk about that in this show as well, and that is a general purpose microcontroller with no connectivity. It's a dual-core RISC-V job, which I think is supposed to really go up against the STM32 and all of that kind of stuff. It's supposed to, it's Espressif throwing their hands into the general purpose microcontroller. What is it? A ring? They're throwing the microcontroller hat into the ring? I don't know. Anyway, there's that, and of course, some funding website things, and all the usual things you would come to expect from an Electromaker show. One thing I will say at the very start is the Arduino clock that I talk about in this show is not something that I can really adequately explain easily. So if you want to see what I mean, head to the show notes on your podcast app or whatever you're using to listen to this. You will find a link to the Arduino blog with a video embedded into there. It is a very short video by the creator of the project, which will give you the visual feedback you need to understand what that Arduino clock project is. And I'll let you, you'll see what I mean when we get to it in the show. As always, this show has no sponsorship. It has no Patreon page, or we don't run ads on the podcast. If you do want to support us, head to electromaker.io and head to our shop and shop with us for your next project. And that is it from this rather mammoth introduction. Let's get on with the show. We are going to start this week's show by looking at a Raspberry Pi Pico project on Hackaday. Now, this is Raspberry Pi outputting video, which we've seen and even talked about on the show before. But this is a little bit different, because this is generating a PAL signal on the Raspberry Pi Pico, which I have been led to believe is an order of magnitude more difficult. Now, I'll be linking the Hackaday article in the description, but you can find the link out to the GitHub I'll be referring to, and also the Twitter account of, the Guru of 3, who is Fred, or Guru3 is the GitHub page. But yes, this is outputting PAL using the Raspberry Pi Pico and using a resistor DAC. Now, the idea of a resistor DAC being that you can output from different pins, and they have different resistor values, and then that goes through a voltage divider, giving a different voltage at the end point. I hope I explained that well. The point is here, it has to be done at such a speed to generate a true PAL signal that the Pi is being just a wee bit overclocked. Yes, 241% over stock Raspberry Pi RP2040 running power. So as it says, not for the faint-hearted. But if we head to Twitter here, you can see it's actually quite impressive. You have cubes moving around the screen, and as it says, a high-resolution 164 by 125 display, color composite video using just a passive resistor DAC on the Raspberry Pi Pico. You can see down here, only a smidge of an overclock at 241%. Now, the GitHub page talks about some of the limitations here, and obviously there are going to be some, and it seems like one of the trade-offs here is between resolution and color depth. As it says here, there was a time, the best you get so far is a super high resolution of 220 by 110 at a roughly 7-bit color depth. There's a few other things worth reading here. The Hackaday article as well is somewhat interesting, just because down in the comments, I know nothing about this, so I have no idea if any of this is right. I mean, comments, I've been a writer for many years. I know the comments aren't always the most useful place. But someone was mentioning that that's the comment that's not particularly friendly. Well, with that speed it can do HDMI, composite PAL output should be possible at 8 megahertz, running mostly on 1 to 3 of the PIO, so channels 1 to 3 of the programmable input-output interface of the Pi Pico. Why is that so hard to say? But he's saying, I suspect, like MPEG decoding, it's the PAL generation that's taking most of the time. If you know more about this than I do, I'd really like to know if this is true or if this is just normal commentary nonsense. But in general, just the idea of generating PAL video, because I was one of the places which had PAL as the output video when I was small. It was all output, and I was very confused at the differences between NTSC and PAL until long after there was no need for them anymore. But yes, another PAL, another Raspberry Pi Pico video project, but this one a little bit more high-tech, shall we say, even if it is completely antiquated by this point. God, I love this. Moving over to the Arduino blog for a project that's actually quite old. It's at least a year old, if not two, but it's something that the Arduino blog has just published now, and I missed it at the time. And it's certainly one that is worth resurfacing and taking another look at, because what a wonderful project it is. This is a digital displayed clock that uses a lot of analog clocks to display digital time. And it does this by having a lot of different clocks. Each one of these panels is an analog clock, so there are 24 of them. But the clocks aren't running as clocks anymore. There is instead an obscene amount of motors and Arduinos behind each one. As you can see, a custom little board attached to each one, and these are all linked together to provide the right time. Seeing it in action is something quite special, and luckily the creator has a video of it. So right now this is in sort of an off mode, but if he turns it on, you will see all of the hands start to sort of spin around and go back to their origin points, I think is how it works. Some of them do, some of them don't. Yeah, okay, so they're all going back to the 12 o'clock point now. And then the bit that really gets me every time is that it all goes back, it does its little calibration, and then it says, okay, what time is it now? It's going to put itself to the right time. And all of a sudden, out of nothing comes, a clock. I love it. It really makes me unseasonably excited every time, probably more than it should. Now, if you would like to know more about this, I'll leave a link to the Arduino blog here. And you can go through to the video itself too. There is an Instructable for this, but I noticed that when I actually went to the Instructable, it did not work. However, if you search iHeart, which is the name of the maker, you can find the Instructable there as well. I'm not signed into Instructables on this browser, so of course I can't follow him. So yes, Ira Hart, it's Ira, not Ian. There we go. I was wondering if he's another Ian. Ira Hart is the person that's made this. Yes, I will leave a link to this Arduino blog just here. But as I said, this isn't all the information you can find on it. You can head through to the Instructables link, and everything I've said was absolute nonsense. The link on the Arduino blog works as well. I was taking a convoluted route for no reason. But yes, things like this really make me smile. There's absolutely no reason to take apart that many clocks to make a clock. But Ira Hart did it, and I'm very glad that he did. We're going to move on now to Dave's Garage, which is a YouTube channel I really enjoy and have done for quite some time. Now, if you're not familiar with Dave, he is an ex-Microsoft employee, and he is now retired and really enjoying his retirement by making lots of YouTube videos on a variety of subjects. He's recently put out a book called Secrets of the Autistic Millionaire, which is basically about his life on the spectrum and things he'd wished he'd known when he was younger. But that's not what we're here to talk about today. However, if you are interested in anything to do with coding and anything to do with the history of Microsoft Windows, and all that kind of stuff. And he's not much of an evangelist. He uses Linux as well. He's a very interesting guy when it comes to that, because he doesn't have to toe any party lines anymore. But of course, he has years of experience with Windows, which makes him a very interesting person. But even just down to the fact that he recently, if I remember correctly, put out a video that I really enjoyed about just programming the Raspberry Pi, called Hello World on the Pi or something. And it's literally just how to get a Pi up and running and how to start using the GPIO pins using the C and C++ programming language, doing remote development over SSH, I believe was the way he did it, and it's great. Not what we're talking about today. Today, we're talking about Pong. So, there was a time where Pong was the game. Pretty much literally. You plugged it into your television and Pong would appear on the television, and it's almost hard to believe, even for the generation above me, I think, that there was ever a time that was the case. However, that's where we are. This is how do you make Pong from scratch in 2023. And as with all of Dave's videos, they are wonderfully well explained, wonderfully well educated. He is a man that has both the time and the resources to really make these things good. And it is very, very good. Now, the video itself is 25 minutes of explanation and saying how it all works, and as always with Dave, he will go through everything you need to know in order to understand it in great detail, along with just pitfalls and things that he comes up with along the way. I really love the fact that, if I remember correctly, he gets an original box but with broken innards that he can reuse or something along those lines. Either that or a very good replica. I cannot quite remember. But yes, Dave's Garage is a fantastic channel. If you are interested in game development, PCB design, the history of computer games, and hearing someone who is a great expert on this stuff talk about this stuff, I would highly recommend this video. And yeah, like I say, I've got a real soft spot for Dave's channel in general. It's unique to have someone with his perspective putting out the kind of videos that he is. And again, he's just put out a book as well. So I will leave a link to this particular video in the description, but there's links to everything else either in his description, or you can head to his channel to find the things that I was referring to just before. If you are someone who is interested in how old things worked and how you can make them new in this day and age, this is a really wonderful video series for you. It is time for funding website things, but we're doing it a little bit differently this week. We're going back to two projects that I talked about in their pre-launch stage before we knew how they do and knew how much they'd cost, and we're looking at them now that that funding has finished. Both of them reached their funding goals, but now we get to find out how much both of them cost and maybe whether you'd like to support the creators by getting these things if you think they'd work in your project. Now, both of these things are on Crowd Supply, which, if you're not familiar with it, is a bit like Kickstarter, but it's just for like specifically cool hardware projects. And this is the perfect thing. This is the perfect Crowd Supply kind of thing. So Blue IO 832 Mini is a either standalone or kind of companion thing for hardware projects that uses it's a Bluetooth Low Energy communication device, basically. The difference being it can be completely no code. They have several apps which can work with it natively that can either read values from sensors or do software. It's a serial interface bridge as well, so you can get serial data from a distance. And there's a couple of other things it can do as well. Let me see if I can remember. Oh, yeah, it has the ADC on it for reading sensors. It has GPIO functions, so outputting and inputting too. So presumably, yeah, so by GPIO functions, I'm meaning digital, and then it has an ADC on it as well for reading analog sensor readings. You can also plug an NFC tag into it as well. But that's the thing. There's a lot of different Bluetooth and Bluetooth Low Energy devices out there. One of the things that grabbed my eye about this originally is that it has that app. So as you're seeing here, they're using it as a sort of little logic analyzer as well. So yes, they only had a $1 goal, so it was always going to work. But they've raised $335 to get this thing out. And if it is the kind of thing that you think you might be interested in, I'll be leaving a link to this page in the description. You can read all the way through it yourself. All the features and specs are here. There's also a comparison chart between it and other things that do kind of similar things. Yes, if you want to get one, it is $40 for the thing itself. There's also little packs here, so you can get one of the little Bluetooth things that sits either with your hardware project, because it can be used with an MCU or it can be used by itself. And this is a little USB Type A thing that is essentially a dongle that can plug into your computer. So this is one end and that's the other. So you don't have to use it with your phone. You can use it for programming as well. And the same goes here. This is a USB Type C version of it. And that's $65 and $70 respectively. So, if you are interested in this kind of thing and you don't want to have to program your own Bluetooth stack, you can find this page here. There's also another demo video of it just here, which is certainly worth having a look through. It's basically using some of the same footage from the promo video, but giving a little bit more technical information as well. Up next, we have Soko Rad 32, and this is one that really grabbed my imagination when I saw the pre-launch page for it. This is a hackable open-source ESP32-based amateur radio board for walkie-talkie and data communication applications. Now, I was one of those kids that really loved the idea of walkie-talkies and never had good ones when I was little. I had those really crappy ones that you could get from the shop that had a very small range, but the idea stuck with me, this idea that you could have your own communication thing. I was just at the right age where that was still exciting for me because mobile phones weren't a thing until I was well into my teenage years. Walkie-talkies had a real magic to them, and this is basically that to me. And also, I just love the form factor of it. I feel like there's a real simplicity to it. You stick your 18650 battery in here, you have your little OLED screen here, a couple of user buttons and an aerial, and a speaker if you want one. And you've got your chip, and that's that. I'm sure they have a fantastic firmware setup that you could use to just get this thing working as a walkie-talkie straight away. For me, I'd love to get a couple of these and more or less just blank them and then try and make my own radio stack just to make my own little walkie-talkie, no matter how it worked, just to understand it. Software-defined radios is something I've been really interested in for some time, but I just do not have the time to get into it. Now, with all of these things, if you are interested in getting one of these, you have to make sure that you look into the local laws pertaining to them. They've tried to make it so the frequency range, it covers most of the country's allocated license-free walkie-talkie bands, so you can do it without a license. Also, it can go from 2 watts down to 0.5 watts in terms of output power. Again, local law. You have to know what's okay in your area. That's something you'd have to look into before you got this. Now, how much is the kit? That's the main reason that I came back to this page, although you might want to come to this page too, because as you can see, they have a lot of different demos as to what it can do and all this kind of stuff. But the board itself is $80 for one of them. Presumably you'd want to get 2 of them, but then again, if you were going to get this to work as a walkie-talkie project with someone else, maybe what you'd want to do is buy 2 of them and give one of them to yourself as a present, and then give one of them to someone else as a present, as a nice little dual project thing that you can work on. I just love the idea of this. As I said before, I really wish I had the time to get into software-defined radios, and this little hardware board is the least sort of intimidating one I've come across so far that really could do that for me, and a microcontroller that I already understand how to program as well. If this is something, I know for a fact there's a few people that watch the show who are interested in software-defined radios and know a bit more about it. If this is something that you'd be interested in, tell me why. If it isn't, I'd also like to know that. And again, if you are thinking of getting one of these, it's definitely worth checking the local laws before you do, because the worst thing is you'd get this thing to the post and then not being allowed to use it, you know? But this thing has reached its funding goal. They got $9,000 out of the 5.6 that they asked for, and it really does look like a lovely little bit of kit. One more for the hackers than people wanting to get just a bit of a walkie-talkie action in their lives. I'm sure you can get good ones for cheaper these days. But yes, what a lovely idea. Now, there is a new development kit from Nordic Semiconductor, and it's quite an exciting one. This is the NRF7002DK, and it is released today. At the time of filming, it has only just gone live, as it were. Now, I have actually had one for a little while. I got one when it was still under embargo. I've had a minimal time to play with it, sadly, just because of how busy things are at the minute in my personal Electromaker towers over here. As I've complained about many times on the show, I spend far more time talking about this stuff than playing with it these days, which is a shame, because this one really is quite exciting. This packs everything that you get in a regular Nordic Bluetooth Low Energy Zigbee Thread Matter development board, but with a companion Wi-Fi 6 IC. That's what the NRF7002 is. It's Nordic's first Wi-Fi chip, and that's actually quite a big deal. So this is the same development board, albeit a much more beautiful photograph of it than I could ever take. This kind of gives you a really good idea about what's going on here. So let's ignore everything except from just the 2 chips right now. Down here at the bottom, you see the NRF7002. This is the Wi-Fi 6 companion chip. Now, Wi-Fi 6 specifically is something that makes this development kit possible. Wi-Fi 6 is by far the most helpful thing for getting Wi-Fi to work with IoT. If you've ever tried to do anything that needs to run on battery power or run on low power, you'll know that Wi-Fi is a problem. It's a massive hog of all kinds of resources when it comes to all kinds of power when it comes to waking things up and being useful in any way. And again, I'm not speaking as an engineer, I'm speaking as someone who's tinkered around trying to get things working with batteries in the past, and yeah, it's a nightmare. This changes everything, though, because Wi-Fi 6 has a number of things, that some of which I'll be honest and say I don't understand at this stage, some of which I do, and I understand why they're such a big deal. And we'll come on to that in just a second. So this development board really is a way of evaluating that IC, but it's a lot more than that as well. Because this is a companion IC. It's meant to work with another microcontroller or system on chip. And in this case, this is the NRF5340, the one you can see in the middle just here, which is already a pretty robust chip. We've talked about these chips a bunch of times on the show. It's the same chip that I believe is in the Thingy 53 as well, which is that wonderful little square development kit. It is by itself a robust Bluetooth Low Energy Mesh Zigbee Thread Matter protocol, all of those things, with the same stack that with NRF Connect, which is the free software stack that Nordic gives you, which even someone like me who's not an engineer has been able to get pretty much every board up and running without much hassle with. This is the 2 things that are the center of this board. And then, of course, you get everything else that comes with it, which is a huge amount of GPIO, an Arduino-compatible pin header, so you can use your Arduino shields with it, an NRF antenna just down here, user buttons, LEDs, and a bunch of different ways of probing power, so you can test the amount of power that your project is using. It's a perfect thing for the, again, power profiling kit, which is another Nordic thing, but you could rig it up to anything that measures power, really. And ways of plugging in a battery or just putting power into the pins, or, of course, powering it over USB. It also has a J-Link Sega debugging and programming tool again, so you don't need any external programming tools. You can just plug this in via USB and off you go. So, what makes Wi-Fi 6 such a special moment, and why does it work so well with Nordic's stack of tech particularly? So what's the big deal with Wi-Fi 6? Well, as far as I understand it, which is not very much, it's the first time that Wi-Fi really is a viable, low-power, Internet of Things, smart things communication system. Bluetooth Low Energy is, well, the clue's in the name. It's low energy. It has a low energy cost. And anyone who's worked with low-powered communication protocols before knows that, especially for short-range stuff, you can do a lot with very little power. Wi-Fi has always been the exception to that rule, and where there are some lower-powered Wi-Fi systems that you can use with microcontrollers, they've always kind of been an order of magnitude higher in terms of power cost. Wi-Fi 6 changes that. So there's a few things that have been concepts that are around for a while, none of which I'm going to particularly try to explain because I don't really understand it. I'll be absolutely honest. But for example, one of the things that I do have a good grasp on is the idea of target wake time. So if there is information that's to be sent out to a bunch of different targets, the idea is, as soon as the base station says, hey, I've got information, everyone wakes up and just waits for it, but they can only receive it one at a time. Target wait time schedules exactly when a base station will send things to each particular place, meaning that they only have to be awake for the split-second moment that they're going to be receiving that data. And that, when you add it all together, will save a huge amount of power. Now, I may have explained it terribly. Feel free to tell me in the comments if I have. And there's a bunch of other features, and if you are interested in finding out more about it, if you just head to the spec sheet for the companion IC, in fact, it tells you this is just the companion IC itself. And as I mentioned before, you could get one of these and incorporate it into your PCB next to a STM32, next to I have no idea, but whatever companion MCU can talk to it over SPI or QSPI. That's how it communicates with the host. But yes, you can find out a lot more about it from the spec sheet. There's a product brief here as well, all of which is available from this DK page, which I will be linking. And you can find everything you need to know about the IC. But while we are here, let's quickly go over a couple of those specs. It's 2.4 gigahertz and 5 gigahertz dual band Wi-Fi. It uses a low power solution, which you'd come to expect from Nordic, and secure Wi-Fi for the Internet of Things. Ideal coexistence with Bluetooth Low Energy, and this is something I've seen across a lot of the release materials from Nordic. They're really trying to stress the fact that this can slot into a Bluetooth Low Energy project and coexist with it. The idea being that it's of the same ilk. When Nordic started working on this, the company that this is all from is a company that they acquired way back in 2020, and it's taken these 3 years to get, presumably, to get it up to spec to work at the same, exactly the same way as all of the other things in their complement of product, right? So the NRF Connect SDK, if you've never fiddled with it, it's free. Even as a hobbyist like me, I've managed to get their boards up and running without much hassle. Makes everything, you do everything exactly the same way, which is nice. It's really kind of useful for someone who's not very engineer focused, who doesn't really understand how to dig through really difficult documents. Everything kind of slots together quite nicely, and I have a feeling that they've made a very big effort to make sure that whatever projects you're already working on with any of the other NRF chips, you can just slot this IC in. Anyway, I am definitely waffling. Anyway, that's a huge amount of waffling, some of which I will probably have to cut out. But if you are interested in finding out more about this, there will be a link in the description to this DK page. It is out now, only just. I've been looking at pre-embargo information. I actually recorded this section once already, but I thought now that the actual stuff is out, I would at the very last minute just record this just so that I can chuck it into the edit at the last minute and get it started again. And yes, there's a wealth of information already up there as to, the idea behind this. I feel like I've given a half-decent idea as to why Nordic are now stepping into the Wi-Fi arena, as it were, throwing their Wi-Fi hat into the Wi-Fi arena. But yes, if you do think I've missed anything, you have any questions about it, feel free to ask me in the comments. But the best thing you can do is come over here and have a look for yourself. There's also a video explaining the idea and the thoughts behind finally coming to the market with Wi-Fi. It's the one thing that they've been asked to do the most. But yes, there is, of course, the one other case that we have to deal with right now is not only do we have this wonderful new thing that's been released to the world, we also have this wonderful thing in my hand that I'm going to release to one of you, albeit in the form of a prize. So yes, as always, the development kit that I have been sent will not be with me for very long. It will be getting sent out to one of you as a prize. And as always, the way that we run these competitions is slightly different to the random competitions that we have in the past. I'm genuinely interested to hear the kind of things that you want to do with this board. And so the way that you can enter the competition is by being a subscriber to the Electromaker YouTube channel and leaving a comment on this video saying what you would do if you had this board. This is Bluetooth Low Energy, Zigbee, Thread, all the things I've said in this, and now Wi-Fi 6 development kit. And what would you do if you had it? What would your project be? And leave the hashtag NRF7002 in your comment as well. And then the way it works is we have a little panel of judges who I basically send all of the hashtagged comments to. They have a read through them and they decide which one they think is the most worthy winner of any particular board that we have to give away at that particular point. So yes, I hope this has been a good introduction to the NRF7002. It's a great idea for companion IC. It's a wonderful looking development board. I know I talk about Nordic stuff quite a lot. I've just been lucky enough, just because of the way Electromaker works, I've had a lot of these across my desk over the time that I've been doing this. Yeah, for someone who, as I've said before, I am not an engineer at all. I know they are used very extensively for prototyping and with embedded engineers who have been doing it for years, and I know that these parts are used in absolutely everything. But even as a hobbyist, I find these things quite fun to use. It's a step up from things like Arduinos, but it's still a hell of a lot easier to follow than some other big name general purpose microcontrollers that are on the market. So yes, the NRF7002 development kit and IC is out, and it's pretty exciting. Now, moving on from Nordic Semiconductor putting out a Wi-Fi development kit to an ESP32 without Wi-Fi at all. This is the news that Espressif are putting out a general-purpose microcontroller without any connectivity. It is a dual-core, super-fast chip that is probably going to retail at quite a cheap price. And the first thing that I thought immediately is, okay, Espressif are going up against ST Microelectronics here. They're trying to make an STM32, but that is an ESP32. And this is clearly what Jean-Luc Anfranc of the fantastic CNX software thought as well, as in the second paragraph it mentions. Yes, it should possibly be seen as an alternative to the STM32, F7H7, or the NXP IRT ARM Cortex systems, or it says the microcontrollers crossover processors. And it'll likely be offered at a significantly lower cost. So yeah, I think we kind of thought similar things about this. But yes, as always, CNX has the best coverage of this when you come up with anything. As you can see, everything is listed here. There's also the block diagram here. So things of note, it is a little big architecture, so it can have a very low-powered, very slow-moving, not slow-moving, but a kind of a simpler core that can do most of the main tasks that you will want it to do and use very little amounts of power, only waking up the big core when it has something more difficult to do. And as mentioned, it is a high-performance CPU with up to 400 megahertz with AI instructions extension and a single precision FPU, along with 768 kilobytes of on-chip SRAM. And then there's also that single RISC-V low-power MCU core up to 40 megahertz with 8 kilobytes of zero-weight TCM RAM. And yes, support for external PSRAM and flash. It has a 2D pixel processing accelerator, which is something I am interested to find out more about. It does mention down here that it does have support for 2D graphics acceleration. H.264 and JPEG codecs will make it suitable for human-machine interfaces with machine learning capability, and the requirements for larger number of I/O are made available by current ESP32 chip. Oh, I see, right, yeah. So it also has all the kind of peripherals you'd imagine as inputs and outputs. Kind of everything that you would need for displays, everything you need for cameras, anything you need for any kind of sensors, along with input and outputs, whether they be digital inputs and outputs or analog inputs and outputs, in that it does have a DAC. We'll have to wait and see kind of what the resolution is on that, and of course an ADC for sensors as well. Yeah, if you are interested in finding out more about it, I'm going to leave a link to this in the description of the video. I'm going to come back to it a little bit later when there's actually more information as to when you can get them, how much it's going to cost, because that's something we don't know yet. It's been announced at the start of this year. I missed it, and then it kind of was like, oh, there's yet another ESP chip that's come out, because the ESP32C6 came out as well, and that sort of, yeah, clouded up the water for me. I didn't even notice this one until much later. So if you would like to know more about it, you can head to the link in the description. I'm sure CNX will be one of the first to report it when there is actually a price and where you can actually start buying them. We will definitely be coming back to them on the show as well, because yeah, an ESP32 without Wi-Fi is enough to raise a few eyebrows, but this looks like it's going to be one of the most powerful general purpose RISC-V chips that's going to come out and be used widely, and I'm really excited to see what happens with it. That was the podcast for this week. Thank you so much for joining me. Thank you for all of the support that you continue to show us. If you have a rating system in your podcast app, it would mean a lot if you give us a high rating and say how much you enjoy listening to the show. No idea if that makes a difference, but it seems like something that's a good thing to do with the podcast. Also, thank you to those of you that have been shopping with us and will continue to do so. All the things that I talked about in the show will at some point wing their way to our shop, including all the Nordic things we're talking about. And we do have a fairly decent stock of most stuff at the minute. And I say most stuff because, it's still hard to get your hands on some things. But I will be away in England at the time this comes out, and I should be back and doing a normal podcast episode in the following week, but just on the off chance that it is delayed, it's just because I have been away for work. It's quite exciting, really. I'm going back to England for the first time since before the pandemic, but unfortunately it's a flying visit just for work, and I shall be seeing no friends or family. But that said, yes, I shall fill you in on the details of what that is all about on the next podcast. But for now, I hope you have a safe, fun, and creative week, and I will chat to you soon.